Hi students, welcome to our chemistry class. In this previous video, we have discussed about silicon tetrachloride preparation, properties and uses. Here we are going to discuss about another silicon compound, that is silicones, also preparation, types and properties of silicones. So the compound is silicone, or we can say polysiloxane, okay, silicones, or you can say polysiloxanes. Actually they are silicon polymers. Okay, it contains organic compound. So the general empirical formula of these silicones are R2SiO. Because this is empirical formula of the silicone, because the empirical formula of ketone also, see the ketone is another organic compound. That empirical formula is R2CO. Actually the CO is the functional group of ketones. So it resembles this formula. So this silicone empirical formula is resembled to this ketone, hence it is called silicones. Hope you understood. Also they have three types of the silicones are there that you will study later, and also they have high temperature, high thermal stability. So you require higher temperature to break this or to decompose this silicones. So it is called high temperature polymers. So silicones or polysilicones, they are organosilicon polymers. That general empirical formula of the silicon are R2SiO. It is that empirical formula is same as the ketone, that like this R2CO, so that it is named silicones. And it has high thermal stability, so that it is called high temperature polymers. The preparation of silicones. Preparation of silicones. So generally silicones are prepared by the hydrolysis of dialkyl dichlorosilanes. Okay, so first you should know that knowledge of this silanes and dialkyl dichlorosilanes. So let me tell you one by one. First silanes we are writing SiH4. This is silanes. Since that silicon valency is 4, the valency of silicon is 4. So here one silicon atom is surrounded by 4 hydrogen atom. Clear? So silicon atom is surrounded by 4 hydrogen atom, since the valency of silicon is 4. Okay. So what will happen? This all the hydrogen atom or any one of the hydrogen atom, if it is replaced by either chlorine or alkyl group we are representing by R, alkyl. Alkyl, it means generally it is a hydrocarbon. For example, if it is C2H6, this is ethane, we are removing one hydrogen atom, C2H5 we are getting, so it is called alkyl. So this generally we are calling alkyl, So this is ethyl. So here this is ethane. Okay, ethane. If one hydrogen atom is removed, so we are getting C2H5. This is ethyl. So that generally we are representing alkyl, ethyl, methyl, propyl, butyl, and so on. Okay, so what will happen? We are getting Si, then one chlorine atom, then R3. If this 3 hydrogen atom is replaced by 3 alkyl group, so we are writing R3, and here one chlorine atom we are representing one chlorine atom. That means how the structure is Si, Cl, R, R, R. Okay, so hope you understood the structure. So this is called trialkyl. This structure is trialkyl monochloro silanes. Now you see generally it is R, Si, then Cl. So R3, Si, Cl1. So for example, if it is R, then Cl, Si in between it will come. If it is 3, here this chlorine will be 1. If it is 2, the chlorine will be 2. If it is 1, the chlorine will be 3. Okay. So I am writing this R3, Cl, R2, Cl2, then R1, Cl3. So in between Si must come. So this name is trialkyl monochloro silanes. This is dialkyl dichloro silane, and this is alkyl or monoalkyl trichloro silane. Okay, hope you understood the names. So the preparation of silicone is the hydrolysis of dialkyl dichlorosilanes. So normally this dialkyl dichlorosilane, from this structure we are getting silicones. Okay, so hydrolysis means addition of water. Hydrolysis, it means addition of add water. Okay, so take this R2 SiCl2, add water. So when you add water, these 2 molecules of chlorine will be replaced. So what you will get R2 SiOH2. Suppose if you take trialkyl monochloro, when you add water you will get R3 SiOH. At the same time you take RSiCl3, add 3 moles of water, you will get RSiOH thrice. Okay, so this is the hydrolysis of alkyl chlorosilanes. So we will see the reaction one by one. So the preparation of these silicones. So first we are going to prepare this dialkyl and dichlorosilanes or diaryl, AR, that is aryl dichlorosilicones. So that is hydrolysis of this compound, we are getting silicones. So to prepare this dialkyl and dichlorosilanes, first take the vapor of Cl or ArCl. So anyone you can take and pass this vapor over silicon. The catalyst is copper and the temperature is 570 Kelvin. So pass this RCl vapor, it is a vapor, on silicon in the presence of copper is the catalyst. This is catalyst, and the temperature is 570 Kelvin. So the product we will get R2SiCl2. Now since it is R2, put 2 here, 1 Si and 2 chlorine atom, so 2 RCl. Now the equation is balanced. From this R2SiCl2 we are going to prepare these silicons. So that is by the addition of 2 moles of water. So what will happen? These 2 molecules of chlorine atom will be removed as 2 HCl. Okay, so the product will be R2SiOH twice. Okay, the structure will be SiRROH. Okay, so after the hydrolysis we are getting this compound. Then what will happen? Again 1 mole of this same compound will be adding, and again the water molecule will be losing. So SiRROH plus the same 1 mole of this compound SiOH, then HOR. So first hydrolysis takes place, then condensation. Condensation means what? Condensation, that is loss of water. So first hydrolysis, then followed by this condensation, that means loss of water. See here this OH and this hydrogen. It will be removed as water. So the product we are getting HOSiRR, then OSi, then RROH. Now here, see here, this is called polymerization. This is polymers. So what happened? 2 monomers joined together. So this one monomer, the single unit is called monomer, and another unit is also called monomer. So when the 2 monomers combine together, undergoes condensation, polymerization. So here loss of water takes place. So we are getting a polymer like this. Again addition of 1 mole of 1 monomer. This water molecule will be losing, that is called condensation, minus H2O. We are getting the product HOSiRROSiR, also here O, because the water molecule lost here. So SiRR, then OH. So this is the polymers, the structure of polymer of the silicon. So this is called silicon. Hope you understood the reaction. So we are preparing the silicon by the hydrolysis of R2SiCl2, that is dialkyl dichlorosilanes or diaryl dichlorosilanes. Okay. To prepare this dialkyl dichlorosilanes, take the vapor of RCl and pass on Si, that is silicon. In the presence of copper as the catalyst, the temperature will be 500 Kelvin. We are getting the product of dialkyl dichlorosilanes. Then do the hydrolysis by adding water. So what will happen? This chlorine molecule will be removed as hydrogen chloride HCl. Here one hydrogen atom, actually HOH. This hydrogen atom will be combined with this chlorine. So there will be a loss of HCl. So finally the product will be R2SiOH twice. The structure is SiRROH. Now what will happen? 1 mole of this monomer is reacting with another monomer. So there will be a condensation polymerization. This is called condensation polymerization. Polymerization, it means a large number of molecules, that is polymer, is formed by the combination of monomer. There are different types of polymerization are there. Here condensation polymerization takes place. Condensation polymerization, that means losing of water. So this kind of polymerization by the loss of water is called condensation polymerization. See here, 2 monomers are combining, 1 mole of water is losing. Then again 1 monomer is adding this R2SiOH twice is adding here. So again water molecule is losing here. We are getting a big polymer, that is silicon. So that's all about the preparation of silicons. So during the preparation, so what happened? Actually the monoalkyl, that is RSiCl3, monoalkyl trichlorosilane, it yields a very complex cross-linked polymer. So this particular monoalkyl trichlorosilane yields a complex cross-linked polymer. Okay. At the same time, linear silicones it can be converted. So can be converted to cyclic or ring silicones. So cyclic means it's like a benzene structure. So the structure will be silicon O S I R O, and again here O, here R S I O S I, then O and O S I R. This is monoalkyl, that is linear silicones. R, again R here R. So the link will be going like this. This is the cyclic or ring silicones. This is cyclic or ring. Okay. So next one, types of silicones. In these types of silicones, there are 3 types. One is linear silicone, another one is cyclic silicones, another one is cross-linked silicones. So there are 3 types. One is linear silicone, cyclic silicone, another one is cross-linked silicone. So we will see one by one the types of silicones. So the first one is linear silicones. Linear silicones, then there are 2 types are there. One is silicon rubber, another one is silicon resins. Okay, so linear silicones, there are 2 types are there. One is silicon rubber, then another one is silicon resins. Okay, so these linear silicones, it is obtained by the hydrolysis hydrolysis, then again condensation. So first hydrolysis, then again condensation of dialkyl or diaryl silicon chlorides. So these linear silicones are obtained by first hydrolysis, then followed by condensation of dialkyl or diaryl silicon chlorides. Then this silicon rubber is a type of linear silicones. Here there will be a bridge of methylene groups. Methylene means CH3 groups. So in between that chain we are getting this methylene group. So it is called silicon rubber. Then these silicon resins are obtained. The blending of this type of linear silicones with organic resins. So silicones plus organic resins or such as you can say acrylic ethers, acrylic esters. Okay, so organic resins such as acrylic esters. So that's all about the linear silicones. Next type is cyclic silicones. So in the cyclic silicones, they are obtained by the hydrolysis of R2 SiCl2, that is dialkyl dichlorosilanes. So from this we are getting this cyclic cyclic silicones. So first hydrolysis, add H2O, then followed by condensation. So finally we will get cyclic silicones. Then the third type is cross-linked silicones. Cross-linked silicones. So it is obtained from monoalkyl trichlorosilanes. So add water, that is hydrolysis, then condensation. We are getting these cross-linked silicones. So that's all about the types of silicones. The first type is linear silicones. This linear silicones, again there are two types. One is silicon rubber, another one is silicon resins. So this linear silicones, it is prepared first hydrolysis, then condensation of dialkyl or diaryl silicon chloride. Then this silicon rubber is in the silicones structure, methylene is added, that is CH3 group is binded in the bridge. Silicon resins, when an organic resins is added to these silicones, normal silicones, these organic resins, for example acrylic esters, so we are getting silicon resins. Then second type, that is cyclic silicones, they are obtained from R2 SiCl2, first hydrolysis, then condensation, we are getting cyclic silicones. Then this cross-linked silicones obtained from RSiCl3, first hydrolysis, then condensation. So that's all about the types of silicones. Next, there is properties of silicon. Actually, silicon, they are polymers, and the nature of the polymers obtained by how the alkyl group is attached to the silicon atom. So there are different types of alkyl groups are there. So the nature of alkyl group determines the nature of the polymers. Then second property is it is oily liquids. So means normally it is occurs like oily liquids to rubber solids. So it exists in both states, liquid state, also rubber state. So this range from liquids to solids, it is determined by the organic groups surrounded in the silicon makes like alkane. So alkane usually, for example, that is methane, CH4 we are saying. So one carbon surrounded by 4 hydrogen atom. So likewise this alkane group, silicon also surrounded by 4 same organic group or different organic groups. So that determine the liquids to rubber states. Then they are thermal and electrical insulators. Usually they never conduct thermals, heat and electricity. And they are chemically inert, means it does not react with any other compounds. Lower number of silicons, it appears oily liquids, and higher number of silicons waxy solids. It's a rigid structure. And the viscosity of silicon oil, viscosity means resistance to flow, like our oil that is what you call coconut oil. Then there are different types of oils are there. So viscosity means resistance to flow. So viscosity of silicon oil is constant, it never change with temperature, so it does not thickening during winter season. So that's all about the properties. So all the properties, so just note down and refer to the textbook and study it. Now the uses of silicons. It is mainly used for the lubrication purpose, for low temperature. So during the low temperature machines, so we are using this silicons for the lubrication. And also it is used in vacuum pumps and high temperature oil baths. Then second use, it is also used to make waterproofing clothes. Then insulating materials in electrical motors and appliances. Okay, so mainly it is used in the insulation purpose. Then when it is mixed with paints, enamels, it helps for the paints and enamels to resist for high temperature, then sunlight, dampness, that means wet condition, and chemicals. So the silicons, when it is mixed with paints and enamels, so these paints and enamels resist to high temperatures, then sunlight, then dampness. Dampness means wet conditions, and chemicals. So that's all about silicons. So we studied about what is silicons and types of silicons, preparation of silicons, properties and uses of silicons. Thank you very much, students.